Hello everyone and welcome to the second episode of Revit Programming using Python, of course. In this episode we're going to try to create instances on a wall. So I'm going to use the same script that I used last time to create a wall based on this line, and then along this line I'm going to create points as parameters, and then on these points I'm going to create or place the instances. So let's take a look at the Revit API, and there you have a method called new family instance. If you scroll down you will find a list of methods that you can use. I'm going to pick this one. It takes the location as like points, the family symbol, element, structural type. So the points, as I said, I'm going to create them along this line using a range of floats, and the second argument was the family symbol. To get the family symbol I can use this method in here. It's called getElement method in the document class. So you type doc.getElement, and then as an argument you will pass the element ID of the instance that you want to place. In my case I'm going to create doors, so I'm going to need the element ID of the doors, and to do that you can just do this, for example, and create a door in here, like any door, this one for example, and then click on it and go to Revit lookup current selection, and if you scroll down you will find the get type ID. So just write down this element ID and we're going to use it. So as I said, this is the family symbol, and then we need an element as a host, which is our wall, and then structural type. If you click on structural type and you scroll down, you have these members. So our door is non-structural, so I'm going to type structure, which is the namespace dot structural type dot non-structural. And the last thing is, if you go to curve members and you scroll down to something called evaluate, to create the points, of course, we have this method that takes a number as a parameter and a boolean. If you scroll down, you find that if you set the boolean on true, the parameter is expected to be in 0-1 interval mapped to the bounds of the curve. So we need to create a range of floats, and as you know we cannot do this in Python, so I have got a ready function to use. So I'm just going to copy this and paste it in my script. So let's open my script. So this is the script. I started from where I left last time. So last time we created a line based on or a curve based on this model line, and then we created a wall. And today, as you can see, so the variable called door sim is the symbol of the door. So doc, as I said, dot get element, and then you type the element ID, and I use the function to get a range of floats, as you can see in here. And then I said that R variable is the range of float. I set it from 0-1 to 0-9, and the step is 0-4. So I'm going to create 3 doors along the line, and then I created a loop that takes these points inside this range and evaluate the line, the ln, which is the line, the previous line, and it sets 1 point, which is a double in here, and true, as we said. And then we got to create our doors using the doc.create new family instance So we used as the first argument a point, which is this one from the line, and we use the door symbol, which is the element ID of the door. We used the walls. In our case, we have only one wall, and then the structure dot structural type dot non-structural as a last argument. And of course, make sure that you open the transaction and close it. So if I click now on run, it's not working. Why? Because ln is not defined. Let's see if ln is not defined. So ln is here. Where is the problem? So commit, start. Oh yes. So the problem here is we forgot to select our line. That's why we don't have any lines. So I'm just going to close it and select my line again. So this one we can just delete it. We don't need it anymore. So I'm going to select my line and go back to my script and open it again. So now everything is defined, and if we hit run, this is it. Our wall based on a model line, and here are our instances, doors in this case, created on a range of from 01 to 09, and the step is 04 from this line. Of course, we're talking about a point at parameter here. So this is it for today. I hope this was useful, and thanks for watching, and see you next time.